So I want to give a quick explanation of how it is that we can use complex drives in the sinusoidal steady state. And the basic answer is that linearity saves us. So if you remember from linearity, there is two basic principles. The first is that if you take a linear function of a coefficient times a variable, you get the coefficient out in front times the function of the variable on its own. That's called homogeneity. And if you take a function of two variables, x plus y, added together, that's equal to the functional response to x plus the response to y. So you can call this superposition. So if you think of a linear circuit and you think of the inputs as being the drives to it, any parameter you pull out, here I've shown pulling a voltage out, you could do it with a current as well, is going to be some linear function of that voltage. That's the definition of a linear circuit. So if we think of, say, purely imaginary drive, so V is real, take J times V as the drive, well then if we just blindly apply these principles, we see that the function of this imaginary drive is purely imaginary. It's the J times the function of the drive. And similarly, this real drive had a real output. And what that means is basically the real and the imaginary parts stay separate in solving the problem. So if we use superposition, we take a real component plus an imaginary component, the solution ends up looking like a real function plus J times another real, so plus an imaginary. And notice the response to the real part is purely real, and the response to the imaginary part is purely imaginary, as promised. So basically, if we drive a circuit now with a complex drive, like V naught e to the j omega t, the real part of the solution gives us a response to the real part of the drive. So it's like we had a V naught cosine omega t drive. So basically that's the rigorous justification of why we can get away with just using a complex drive and then later taking the real part to give us the solution to this real drive, cosine omega t drive.